So I would be describing problem 5-57E, which is an air flowing through a ventrimeter, whose diameters are different, and the gauge pressures are measured at both the entrance and the throat. We have to show how the volume rate can be expressed as the equation shown above. So what we do know is, the diameter of the entrance is 2.6 inches and the diameter of the exit is 1.8 inches. We know the pressure at the inlet and the exit, and we need to find the volumetric flow rate. We can assume there's no elevation change, which means Z1 equals Z2, and that there's constant density in the process. The properties we're given are density of air is 0.075 pound mass per feet cubed. So the solution is we take our Bernoulli's equation and we rewrite it to solve for the pressure differential with taking into account the negligible elevation change, which equals to density times velocity, the second or exit velocity squared minus the entrance velocity squared over 2. And with constant density, we can assume that the volumetric flow rate is equal between the entrance and the exit, which means the area times the velocity of both entrance and exit are equal to the volumetric flow rate. So we can solve for V1 and V2 in terms of volumetric flow rate and area, and we can then plug those into the Bernoulli's equation rewritten for P1 or for the pressure differential of the equation, which is shown below. Now we can solve for the volumetric flow rate by rewriting the equation and by plugging in all our numbers into the equation and converting to feet cubed per second using conversion factors. We get volumetric flow rate is equal to 4.48 feet cubed per second.